Math is an important part of everyday life. In this video, we'll visit two classrooms to see how modeling with mathematics can help students solve problems in real-world situations. Watch as teachers use a variety of strategies to guide students into finding their mathematical pathway.
I like your idea. You made a trapezoid, but what did you use? You used a small triangle and what?
A parallelogram.
A parallelogram. I had interesting conversations with tables about this shape specifically.
When I look at how I'm going to use modeling, what I always think about is that math is abstract to all of the students. So I try to figure out what's a way to bring that abstract idea to life for them. The models should be concrete. The model should be pictorial. The model should be number. And the lesson that we did today was really a good showing of the different types of modeling that we can use. The focus of this lesson was to help students see that fractions are represented in lots of different ways. I use a concrete representation. I feel like it's so important for students to have time to experience that representation. Even though it's a quick 2-minute, 3-minute exploration, it's really getting their minds warmed up not only with the math, but also with that model. I mean, this is formative assessment at its best.
I'd like you to share some observations that you made about the 7 shapes that were in your bag. I'm going to record a class list of our observations on the board. Anybody want to share?
It just allows me to see what they're thinking. It also, when you let them be open-ended like that, it gives you an idea of what kind of math is on their brain.
I know you can, but...
Make these into squares. Okay. We make these into squares, we can put some together because of this one. We just need to figure out a way to make them into squares. Or rectangles. Rectangle, oh, we did it. We did it, so then we can...
Something that should be really important to us as math teachers is students generating math talk. So by working with a partner, that person is their sounding board. That person often creates an atmosphere where I'm more comfortable saying this because it's with my peers, so I'm gonna try this idea out on this person, and depending on what they say back, it'll kind of validate my idea.
Keep your paddle up if you'd like to explain your thinking.
I also believe in scaffolding the student talk. So they started in pairs, but then the activity then led to more of a whole group discussion where small groups or even individuals were sharing an idea that was created with another person. And then I took that model, that concrete model, and I changed it a little bit to a circular cake, and I cut the cake into fractional parts. And we assigned an amount of money to each piece of the fractional part. Are you thinking in your head right now what fraction of my whole cake this represents? Are you thinking in your head, I know how much that piece of cake would cost? Although it's real world math, it's abstract to them because how do you get from there's this piece of cake to this piece of cake costs $5. So students need to be able to see it. And that's where modeling is so important.
1 times 20 would equal 20, of course. But then if I did half, which is half of 1, then you would also put half of 20, which is equal to 10.
Okay, so when you say 1/2 times 20, it's like saying half
of
20
is equal to $10.
Is equal to $10. Excellent. We then moved away from a concrete model, and students were given pictorial models of different cakes.
Your task with your partner is going to be to see if you can find the cost of each piece of cake for Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday's cake.
And it's once we get to the number representation that we really can understand what students have gotten out of the math.
Because each piece of cake is 1/4 of the whole cake. So 10 would be the amount of money the cake costs, and 4 would be the amount of slices there are in the cake.
And 250 will be the cost of the slices.
The exit ticket at the end was another cake. It was a square cake cut into various sized pieces. I'll use that exit ticket as a formative assessment piece to let me know who has understood how to find part of a whole when the whole is not one, and who's able to use a number representation or a number model for that. As math educators, we need to know that we're not going to use the same fraction model every day. Using the various models allows us to reach all of the learners versus this one model that might work really well for this 10 kids. By varying the model, we ensure that all students are learning the math. This idea that math is everywhere is really a critical focus for us as educators. If we want students to enter fields in STEM, we need to help them see that math is everywhere and everybody can do math.
So this would go here and here. Hooray!
So that as they enter 6th grade math, and then one day enter 9th grade math and college math, and math becomes more abstract and possibly less contextual, they have these models that they remember from early on working with fractions to connect to.
In this lesson, modeling is a really important factor because we're taking a real-world problem and we're applying math to it. And so we're modeling with mathematics based off a real-world application. The students first looked at a video from the 2012 London Olympics of the 100-meter dash. They just asked them what they noticed about the video, because it's really, when you're just watching the video or you're looking at the Olympics, you're not thinking about the math that's there, but there is math there.
Is there any math in this video?
The probability or chance of someone running the race.
So then I put up a picture of the 3 winners, and it's clear that Usain Bolt is taller than the other 2 sprinters. And so the question naturally arises, did he win because of his height? Does he have an unfair advantage because he's taller? And so the students think that that is the case, and then we start to think about, well, is there a way to figure that out?
Raise your hand if you think that being tall would give you an advantage in sprinting. Well, that's a majority. Look at that. Almost every hand is raised. Why? Why do you think that being tall would give you an advantage if you're sprinting a distance?
We could test it out and see who wins. Like, if we tested this class, we could see who the tallest is and who would win.
You can use like past statistics of people that might have been like the same height.
We really want the students to think about what math could work here and what method could I use. In this particular lesson, students were starting out with ratios, and that was their initial model.
Can we set up a proportion?
A proportion would be a really good idea. What would that look like?
100 meters for the 100 meters time.
Some students turned it into a proportion. Some students did it a little differently. Some students looked at it in terms of running a percentage of what they ran overall. We're formulating a problem, and then we're creating a mathematical model to analyze and support a conclusion that may or may not work. And sometimes with modeling, you may start on a path that makes sense, but then you have to reanalyze the model that you apply to whatever the problem is or the math that you're using, and you may have to make adjustments, and that's okay too. That's all part of mathematical modeling. I'm listening for them to think about the problem in terms that they are comfortable with.
What do we need to do to this number, 1.96 meters, to get exactly how many times his height he ran?
You could divide 100 by 1.96.
Exactly.
If students are struggling with the model, then I would go back to some estimation and ask those questions to get them thinking about approximating an answer or looking for a mathematical practice that would work for, or an application that would work for this type of problem. So you can guide them in those directions.
This distance is based on 1 second. This distance is based on, we don't know.
Yeah.
So we know
this long divided by this long to try and figure out how long.
Right, exactly.
Sometimes it even sparks a new idea, and a student might be, well, we could try this, and then they can help each other.
And his new distance he's running, which is 91.8 meters over a variable, and then you solve it. Thank you.
All too often, teachers are the ones saying, this is the way you should solve this problem, this is the math I want to see you use, and they're giving that students that one pathway. And we want students to kind of have multiple pathways to solve a problem. We really want students to have that kind of modeling experience because we want them to be global thinkers. We want them to be able to think on their own, and we want them to be able to see the math, not just in their math classroom. We want them to be excited about mathematics and look for the mathematics in order to prepare them better for the world around them.